In this video, we are going to see some more interesting tips for UG and PG project. First one, an exploration on certain mathematical curves. So mathematical curves means you can have it as algebraic, parametric and polar curves. You can give a historical background, equations and applications of them. You can give introduction as what are mathematical curves, why to study about mathematical curves, how are mathematical curves named, what are the different forms of mathematical curves, and what is the main objective of the project, and how you are going to chapterize your project. Now, if we consider algebraic curves, you can have elliptic curve, lemniscate, and whatever Cassini ovals that in detail if you want to give, you can give. If you are considering more and more curves means a basic definition, properties and applications, it is enough we mention. Of course the equation is to be mentioned. So definition, equation, properties and application should be mentioned. In the same way parametric curves, there are a lot of parametric curves, you can consider few of them. So for circles, you know that x is equal to a cos theta, y is equal to a sin theta. Theta is the parameter. And you have cycloids, Lissajous curves. So again in this definition, equation, properties and applications can be studied. Then polar curves, cardioid. In real life, you can see the cardioid being present here and in the coffee mug. This is an interesting one. And logarithmic spiral or equiangular spiral, what you see in your one of your vegetables. Then how will a Cartesian grid look like? Any point is represented by the coordinate with first component x, second one y. Then polar grid will be like this. Any point is given by r and theta. The relation between x, y and r theta is given by x is equal to r cos theta, y is equal to r sin theta. All these can be mentioned. Then with the first one, certain curves we have said in that algebraic, parametric and polar curves we had, and then specifically your project can be on Bezier curves and their applications. This is also a nice topic. And chessboard graphs. So in this, it's a graph discussed in graph theory. So at the UG level also you can do, and at PG level also. In depth if you are doing means you can do it at PG level. So chessboard graphs in graph theory are graphs where each vertex represents squares on the chessboard. Edge means it has to connect two squares. How they are going to be connected? If they can be reached by a specific chess piece. Now different pieces like king, knight, rook, bishop, queen result in different types of chessboard graphs, and the most common chessboard graphs: king's graph, knight's graph, rook's graph, bishop's graph, queen's graph. Two squares are connected if they are adjacent, sharing a side or a corner. So all these properties, I mean, how do you get your the king's graph and etc. They must be mentioned, and these graphs, their application, so that can be mentioned. They are used in various mathematical and computational contexts, including studying graph properties, coloring theorems, and computer chess algorithms. So both at UG and PG level they can be done. Then another interesting one is integer sequences in various fields of mathematics. So what is OEIS? That can be mentioned. Online Encyclopedia of Integer Sequence, and importance of integer sequences in mathematics, and you can highlight their significance across different mathematical domains. Next comes the mathematics and chemistry. So in that you can give the title as mathematics and buckyball. So the most beautiful molecule is often considered to be Buckminster fullerenes, namely C60. It is also known as buckyball. This is due to its unique spherical structure composed of 60 carbon atoms arranged in a way that resembles a soccer ball. Now, why this buckyball is considered beautiful? Because of its symmetry and structure, it is considered very beautiful. The C60 molecule features a high degree of symmetry with 12 pentagons and 20 hexagons arranged in a way that forms a closed spherical cage. So it is like this. You have that buckyball. So this symmetry is a visually striking and intellectually fascinating aspect of the molecule. So you can study about this buckyball. Then circles we have mentioned already, and in particular as a special in parametric curves we have studied. I have mentioned already, but separately also about circles, the project could be. So you can mention about the origin. I mean, how who named it as circles and who studied about it. So all that can be mentioned. Their Cartesian form, then the parametric equation. The following properties of circles can be mentioned. All this can be mentioned. Concentric circles, properties of concentric circles, examples of concentric circles in real life, tree rings, uh, water ripples, onion layers, dynamics of circular motion, airbillows. In airbillows, you can give a lot of explanation. So this is how it will look like, and this is used by shoemaker. This is shoemaker nice. So an airbillows is a geometric shape formed by three connected semicircles. These semicircles shape their endpoints and are situated on the same side of a straight line known as the baseline, which contains the diameters. The name airbillows comes from the Greek word for shoemaker's knife due to its shape. Prime numbers, they can be studied, especially in that prime spiral, commonly known as Ulam's spiral, is a graphical representation of prime numbers arranged in a spiral format. The spiral consists of positive integers arranged in a square pattern with prime numbers specially marked. This unique visualization reveals unexpected patterns, notably prominent diagonal, horizontal, and vertical lines that contain a significant concentration of prime numbers. So the Ulam spiral is an arrangement of numbers upon which the prime numbers tend to fall on certain diagonals. It may begin on any integer and may be oriented a few different ways. But the version most commonly presented begins with 1 at the center. So it is like this. So 1, 2, 3, 4, 5, 6, all the numbers are arranged in a spiral format. So in this, if you look at the prime numbers 1, 3, 13, 31, so it is in the diagonal. And similarly here 1, 5, 17, 37. So you have the Ulam spiral being given by this. So apart from that, you can talk about circular prime, absolute prime, deletable prime, Cullen primes, and Fermat primes, palindromic primes. The next are dynamic projects. I will always go for this dynamic projects that you can do using GeoGebra. Some of the topics what you can consider are partial derivatives and tangent plane, visualization of problems in 3D as well as in 2D. Next is you have a lot of project ideas in this website. So if we go to this wolfram.com web page, you have got algebra, applied mathematics, calculus and analysis, discrete mathematics, foundations of mathematics, geometry, history and terminology, number theory, probability and statistics, recreational mathematics, topology. So if you are interested in algebra, say, then you have got topics like this. So in that you can choose one, and you can study whether you are at UG level or PG level. So accordingly you can choose your topic and work on it. So you have got a lot of ideas in this. If you concentrate on this itself, lot and lot projects can be done at UG as well as PG level. These are some more interesting graphs which you can find in encyclopedia. So a bull graph, butterfly graph, all this you can based on certain concept, you can arrange them and you can work on it. So these are a few interesting topics. Now, life is a math equation. In order to gain the most, you have to know how to convert negatives into positives. Thank you.